Hello, ladies and gentlemen, and welcome to the screencast lesson for the first of the lessons on equation of a hyperbola. Hyperbolas are curves that open opposite each other. Okay? So, just like the ellipse and the circle, the hyperbola has a center. Okay. In this instance, it's the center. The center is the midpoint of the segment um, drawn between the two focus points. Okay. Instead of going through all the vocabulary on its own, let's take a look at the standard form for the equation of a hyperbola, and we'll see how it's the same and how it's different than the ellipse and the circle, and we'll go from there. So if you look at this, you have x minus h squared and y minus k squared, okay, same as the circle and the ellipse, and the center is at h comma k. Now, if we look at the two different versions of this. One of them has the x terms first, the other one has the y terms first. But the x term still has the h with it, and the y term still has the k with it. So just be careful of that as we move forward. Okay. And you'll also notice that regardless of what the numerator is, the denominator, the first denominator is always a squared. Okay. Unlike an ellipse and a circle, there is a minus sign between the two fractions. Okay. So the center is still h comma k. It's still equal to 1, by the way, just like an ellipse. So the two focus points. It talks about h plus or minus c, okay, on this side. So you're taking the x value of the center, and you're adding or subtracting the value of c. So I'm going to try out a new tablet, writing tablet. And on a hyperbola, c, okay, let me try this out here. I think I have to get a pen and a color. Okay. So, c equals, all right, that's not good. Let me erase that. So we're going to have a little adventure with the tablet here. But bear with me a minute. So c is equal to the square root of a squared plus b squared. So unlike c in our previous, in the ellipse, c was the square root of a squared minus b squared. Here it's c is the square root of a squared plus b squared. Okay? All right, so when the x terms are first, if I scroll down, the parabolas open left and right. Okay? So if we look at this, we'll see that the parabola is opening left and right here as opposed to up and down here. So when the x terms are first, like this one, like x minus h squared, the parabola opens this way, it opens left and right, and the two focus points are here and here. The two red dots here and here, those are the vertices. So if we look for a vertex, we're going to get 2 when we're looking at equations of hyperbolas instead of 4 like an ellipse. Okay. The transverse axis is the line that connects the two vertices and the two focus points. That's the horizontal line here. Okay. If I look at the equation where the y terms are first, okay, that means it's opening up and down like this. The blue curves are the asymptotes, the hyperbolas, right? The two red dots here are the two vertices, and you have your two focus points. So when the y terms are first, it opens up and down. When the x terms are first, it opens left and right. Now it talks about the equation of the asymptotes. Well, the asymptotes are the red dotted lines here, okay? they cross at the center of the ellipse. All right. The center is the midpoint of the two focus points. It's also the midpoint of the two vertices. So the two asymptotes cross there. If you look at the curve of the hyperbola, it will approach the asymptote line, but never touch. Because that's the definition of the asymptote. Okay. So over here, the blue lines will approach the red dotted lines, but they'll never touch. And if you look at this is point slope form for the equation of the line. Okay. So let's take a look at a real hyperbola problem. It'll be one example. You'll have to replay the screencast probably. All right, there's a lot of little details in hyperbola, much more than the ellipses and the circle. So let's look at this equation. X squared over 25 minus y squared over 4 equals 4. Okay. The x terms are first. That means it's going to open left and right. Okay. Now, 25 is a squared, 4 is b squared. So a is 5, b is 4. 2, excuse me. A is 5, b is 2. Since it's just x squared and y squared, the center of this is at the origin. That's where I put this dot, and that's where the two green asymptote lines cross. Okay. So from the center, the vertices are going to be a distance left and right, okay, because the x's are first, so it's opening left and right. So if I count from center, I go 5 spaces to the left, I get this red dot. I count 5 spaces to the right, I get the other red dot. So when we draw this, the ellipse will start here and come out and approach the two green lines on each side, but never really touch. Okay. So I have the center is at 0, 0. A is 5, B is 2. Okay. So I have my two red dots, and if you see this box here, okay, when we look at the box, that's going to be a rectangular box. A is 5. 5 spaces this way, 5 that way. That means the box will be 10 spaces left to right, or 2A distance. Okay. B is 2, so it'll be 2 up and 2 down. So this box here and this box here will have a distance of 2B or 4. Okay. And that box is important. It's not a requirement to draw the box in, but it helps to draw that because the asymptotes will go through the vertices, the 4 corners of that box. And so the vertices, the asymptotes actually become the diagonals of that rectangle, and then we extend them out past. Okay. The focus points, C is equal to a squared, square root of a squared plus b squared, or the square root of 29, or about 5.4. Those are the two purple dots. I have a purple dot here and a purple dot here. So I take the h, right, is h comma k, so 0 plus 5.4, 0 minus 5.4. You have to remember the focus points will always lie in the interior of the hyperbola, the way the focus points always lie in the interior of the ellipse. Okay. The transverse axis, meaning connecting vertex to vertex, the length of that is 10, or 2a, right? Remember, a squared is 25, so a is 5, so 2a is 10. And the conjugate axis, 2b, right? B is 4, b squared is 4, so b is 2. 2 times 2 is 4, 2 up and 2 down, right? Equations of the asymptote. Okay. If we go back and look at y minus y1 minus y1 equals slope times x minus x1, x1 and y1 here are 0 and 0 because the center of the ellipse is 0, 0. So if we look back here, go back to the previous page, the equation of the asymptote. When the x terms are first, the slope of the asymptote is plus or minus b over a. So in the example I just showed you, b was 2, a was 5, so the slope is 2/5 and negative 2/5. So that may make a little more sense if we start at the origin, up 2 over 5. Start at the origin, and the other asymptote is down 2 over 5, so plus or minus 2 over 5. So what those two lines are. Okay? So, actually, yeah, why did I write 5 halves? That's a typo. It should be 2 over 5. Let me try and correct that with my pen here. I don't want to do that. You have to bear with me as I try and use this pen here. Plus or minus 2/5 x. Alright. I'll practice more with the pen. Hopefully I'll get better with it. So the only other thing that we need to look at is drawing the ellipse, the hyperbola. So this is going to be an adventure. Let's try this again. I tried it a couple of times drawing it by hand. Let's see if I can do this now. So I'm going to start here, the red dot. I want to come down here. Oh, I crossed the line. I want to cross the line. I want to be asymptotic to that line. Let me try it again. Maybe I'll be more accurate on this side. Okay. You kind of get the idea, I hope. We're going to do more of these in class. I think my drawing on the smartboard may be a little bit better. Oh, that was bad. That was bad. Don't laugh too much. Don't laugh too much. All right, that's not good either. I got to practice with this pen tablet that I have. I'll practice a little more. So anyway, the hyperbola will open left and right this way. I started, if you notice, at the red dot, which is the vertex. Drawing. I want to be inside those green lines. I was outside a little bit. I guess my coloring is not good. I have to practice coloring. I color outside the lines. Okay. The two focus points are in the interior of the hyperbola. Okay. So go back and take a look at this. If you look at it, this example right here, with the x terms at first, all the information from here is what I used on the example problem I just showed. Okay. I'm not going to put a quiz on this. The hyperbola is probably the most complex thing that we've done so far. Okay. So take a look at it. Play it again if you need to. We're going to go over this in class. And so thank you for tuning in to the lesson on the first lesson, the equation of hyperbola.